So when you open up Etabs, this is what you come to. You go to file and you do new model. Okay, so as soon as you do that, this is the dialog box which will appear. Now we are using Indian codes, right? Now if in case you don't know, in case you are very new to the software, let me explain what these things are. So if you use saved user default settings, basically the software is will actually pick up US codes for you, and you cannot change these things. Okay, use settings from a model file. So what is supposed to do is you're supposed to give a model file to it. It'll have a settings like all the limitations and codes and everything already pre-installed into it. You'll be modeling your file into that model based on that model. But as we don't have anything right now, from that perspective, we'll go for the third option, which is use built-in settings with. This is what we go for every single time because we're using Indian codes. We have different codes also. So generally we go for Indian because that's what we're designing in. So display settings we go for display unit is we go for metric SI. Steel section database we're going for Indian. See, as I said, there are many more options. Like if you're designing a building which is based in Europe, you can take Euro. If you're designing Russia, you can take Russian. You can do like Etabs is very has a very vast library in it. So we go for Indian for now. Steel design code IS 800. Concrete design code IS 456 2000. All right. So if you have to change anything, all you have to do is come here and pick the code whichever you want. You have even Chinese codes in this. Okay, so that's what we're going for now. Indian codes, we're using steel code as IS 800, concrete as IS 456 2000. Okay, so let's hit okay. Okay, so in this thing, in the very first model we're using grid system, and that's what where we are right now. In grid system we have got two options. One is uniform grid spacing and custom grid spacing. Uniform in the sense it's self-explanatory that all the columns and all the beams will have uniform spacing in them. All right, so in x direction there are four columns, each is at 8 meters center to center spacing. In y column, in y side there are four columns, each at 8 meters center to center spacing. Okay, so this is basically a very mundane case where you have everything very simple. In second option, custom grid spacing, this is what we use majorly. Custom grid spacing, we go for edit grid data. All right, and here you can give your own name. If it is a building, some generally buildings have their names like B1, C1, block 1, block 2, something like that. If you want to give it a name, you can go ahead and give it a name. And here also you have got two options. One is ordinates and one is spacing. Ordinates is basically you have to think of a graph sheet. We have got x and y coordinating graph sheet, right? 0, comma 0 is the origin point. So basically what happens is if you can see here, this is a pictorial representation. A, B, C, D is there. A is at 0. Alright, it's an x ordinate. So in x direction, B is at 8 meters from A. C is at 16 meters from A and D is at 24 meters from A. So everything is taken from the perspective of A, from the point of view of A. Or because there's an ordinate system. Same thing goes for 1, 2, 3, 4 also. Here also everything starts from 1 here. So all the distance is taken like that. But generally speaking, this is not how we do it. We go for spacing. In spacing, what happens is the distance between the two objects is taken into consideration. For example, A to B is 8 meters, right? So A to B is 8 meters and B to C is 8 meters. B to C is 8 meters and C to D is 8 meters. 8 is there. After D there is nothing, so it is 0. Now for example, if I change it here, if I make it 6, alright, see the spacing between A and B has shrunk, like gone down a little, but other things are same. If I increase it here, so the spacing between B to C is 10. See, the spacing increased. Okay, C to D is 8 meters. I can make it 4 meters also. Alright. So, as it is the very first model, let's not play with the grid for now. Okay. Same thing you can do in Y direction also, no issues. After you have done this, just hit OK. What we have done, you can change the name. You have to make it as a grid from spacing perspective, not from ordinates, from spacing. After you have done that, we can change the readings if you want. After you have changed all the readings based on the AutoCAD drawing, AutoCAD, if a column and a column layout is generally marked from uh, grid perspective itself. So if you know the grid spacing, you can definitely do it. Like someone has taken a photograph of the grid and I've sent it to you. You have to model it. You can model it like this. Okay. So hit OK then. All right, we'll come to the simple story data now next. Okay, and we'll hit OK. Before that, again we have so many options here. Now, for example, if you don't want to use grid, you're importing a model. In that case, you have to hit blank and hit OK. If you have something steel text, if you have got staggered truss, so these are like inbuilt templates which are already existing in the Etabs, which you can use and you can modify them as in how you like. All right, so we're gonna use grid because the first model is based on grid and hit OK. So basically what we have done, we have just given the codes, that is Indian code IS456, IS800, and then we have come here, we have selected custom grid spacing, and here we have gone for spacing here again, and we have seen how if we vary this model will vary. Okay, and then we have selected grid only option and we have hit OK. Hitting OK is very important. If you close the dialog box, all your settings will go. So always remember in Etabs, whenever a dialog box appears, close it by hitting OK or apply. Fine, when you do that, after you have done that, you will get models here, something that looks like this. Now, when I teach students, generally what happens is by mistake they close this window and they don't know how to get it back. Simple thing to do is just click here and do add a new window. Alright, you close this by mistake, hit this button, add new window. As simple as that. And if you don't have all these options here, just right click it and you can get all the options whichever you want. All right, so options like this will appear. Now this is our basic thing. Now as you can see in the grid, we had taken 8 8, right? We didn't change anything. A to B is 8, B to C is 8. So this is basically a square kind of a grid system. All right, so basically what did we do? If we come from this perspective, we have entered the input data. All right, we haven't entered the codes. We have taken metric SI as our unit system. Now the next step is define new materials. So how this goes about is, once you have done this step, you have to go to define. Okay, and I have to go for material properties. Now there is no thinking here. All right, you don't have to think twice or thrice. Okay, what is the next step? When you're designing a building, you need material for it. So you have to click on materials. After that, you have to select section properties. So first we go for material properties. That's it. Okay. Now these material are use based. PSI, everything is there. They are use based. If you want, you can click them and you can do modify and you can change all these values and everything. But I generally not prefer that. I rather take my own values. So do add new material. All right. Region, India, material type, concrete, and standard is Indian. Grade is M30. You can use any grade you feel like. I'm going to go for M25. That's it. Okay. Alright, M25 grade is there. Now weight per unit volume 24.99. It's actually 25, but this also works, no issues. Modulus of elasticity E. Now if you don't know the value of this, you can go for our code, IS code, right? In IS code, I think it's in yeah, it's in page 16 here. The modulus of elasticity. See, and the modulus of elasticity. If you don't know this value, all right, for example, if you have done some experiment and you have got your density is different, okay, you can change the density. Elasticity is different, we can change the elasticity. All right, how do you do that? You have to calculate it. Basically, how do you calculate it is 5000 root fck. Okay, you have got fck as 30, 32, 33 something. So 5000 root 32 or something, you do, you get your own modulus of elasticity from there. Just input here. All right, Poisson's ratio, if you have manipulated Poisson's ratio in an experimental project, you can manipulate that. And even coefficient thermal expansion also you can manipulate here. And coefficient thermal expansion also plays a very big part. If you want to use different coefficient thermal expansions, you can come to page 16 and you can use from here also. Okay, so there is no issue in that. All right, so what did we basically do is, we went to define materials. In that we did add new material, Indian, material type is concrete, standard is Indian, grade is M25. Okay, all the settings are default, you don't have to touch anything, and just hit okay. So your M25 is defined. The next material, okay, Indian is there. We don't use, okay, basically what happens here is, we have generally the habit of calling steel as, we call it steel, how much amount of steel you're providing. But in this field we don't call it steel, we call it rebar. Steel is used for steel structures. rebar is used for using those bars which we provide inside the concrete. So rebar you have to select Indian again. So there are four different quality of rebars. Okay, we'll be selecting HYSD 415. We apply it. Again, if you want to, you have come up with your own HYSD bar, something new in the market which is not there in Etabs predefined. You can take the values from the contractor, you can input those values here, and you can see how the building will behave when you put these kind of values into it. Alright, so HYSD 415. Okay, again add a new material. We go for HYSD 500. Okay, again hit okay. Don't change anything, keep the things as they are because they are taken from the code directly. So what we basically did, we have defined three materials, concrete and rebars for it. Now if you want to delete these four properties, you cannot because they are default properties. Now basically if I just close this option, okay, all this table will go. So you have to just hit OK. Let me just show you once. I have defined this three, right? I'll close it. See, they're gone. So it's very important that you hit OK and close the dialog box always when it comes to Etabs. We have to go for concrete. M25. Hit OK. Alright. So M25, HYSD 415, HYSD 500. So what have we done? We have define the new materials as concrete and rebars. We have defined that. Next step is to define frame sections. So we go for define section properties, frame sections. See, everything is there. Define material properties first, then section properties, and in that also very first option, frame sections. So you don't have to remember what to do, what not to do next. Okay, frame sections. Again, in frame sections by default, we have got some properties here. If you remember the very first time when we opened the file, we started Indian Steel database, right? So from the database, we have got all these properties. We can delete them, no issues. So now we have to add new properties for beams and we have to add new properties for columns also. So I'm going to go for add new property. I'm going to hit concrete. See, there's concrete, steel, special, and steel composite. We are going to go for concrete first. Hit the concrete option, rectangular in that, and you come here. Now this is also very important, please note this down. Always name your members properly. If it is beam, mention it as beam. If it is column, mention it as column, because later on what happens when you're doing bigger buildings and everything, you will have far too many beams and far too many columns and you'll get confused what have you assigned where. Okay, so generally beam section is 200 cross 400 mm for small building like this. Material is M25. It is very important. What is beam made up of? Concrete material. So M25. Alright. So again here width is 200. You can see the presentation here. Width. This is depth. Okay. Width is 200. Depth is 400. Okay, many a times what happens, people don't change the values here, they add the values here but they don't change it here. So always keep an eye out for the picture. If the picture is looking somewhat awkward or different, please come check the values and then change it. Then modify by show rebar. We hit that. What are we doing? We are defining a beam structure, right? So we have to go for beam design only. And here also longitudinal HYSD 500, the long bars confined at ties HYSD 415. Now there is a bit issue here because our code basically tells us that I think it was the page number I think it was 73 someplace. 73, yeah. Okay, so if you come to page number 73, it is basically telling us that the stirrups or the bent up bars, okay, shall not be taken greater than 415 per mm square. All right. So if I come here and provide confinement or ties as 415 by code, I'm doing it correct. But the problem is that on field people are not using 415 anymore, as far as I know. Okay, they generally don't use 415. They're using HYSD 500 itself. Whatever comes to the field, they bulk order everything up and they use it. If you know some contractor who sells applying 415, that is good. But this is also very important to communicate between the field and the site. See if they don't have HYSD 415, see what they have and provide the same thing in the model. So HYSD 500 in general. All right, that's the one thing. And then you can see cover to longitudinal rebar. We have got 60 mm and 60 mm. All right. So how do we come to that 60 and 60 mm is basically we go to page number 47, I guess. Page number 47, yeah. In page number 47 we come, you can see here, see nominal cover. Okay. So based on these two criteria, you decide what kind of cover you're going to provide. Okay, if it is half an hour, if you have a commercial building, there's generally more fire resistance provided. If you are like providing for 1.5 hour in beams and it is continuous, something like 30 or something will come, simply supported 40 or something will come. So basically you have to look into all this consideration, decide. It also depends if you have built up your building somewhere near the coastal regions, like we have got Kerala, we have got Chennai and everything. So in those places, the condition is more, adverse. So you have to take even those things in consideration and then decide what is going to be the normal concrete cover. Okay, basically for now, let's leave 60-60. Let's not, change it. And if you're doing a earthquake resistance building, the time this ductile beams will come. Ductile beams nothing but we have provided more steel in them. All right. So there again, you can make all these changes, but that's very advanced. For now, a smaller building like this, let's keep it 60-60 beam. Okay. Okay. So basically, what have we done? We have provided a beam. All right, let's go for delete properties, delete multiple properties. We don't need all these properties. These are extra. They'll just confuse us later on. Okay, we have got just one property. So basically what did we do? We went for add new property. We set it concrete. We gave proper name. For now, let's keep beam 200 cross 600 or something like that. Material we selected what? We selected M25. It's a reinforced concrete M25. Then look at this picture. See 200 cross 600 we have to provide. Does it look like 200 cross 600? No, right? So just change it 200 cross 600. Okay. After that, modify by show rebar. We're designing beam here. Beam. So beam. More design beam. HYSD 500. HYSD 500. Both of them should be 500 500. On field, this is what is being done. If you want to go by the code, we can change it to 415. It is not wrong. Okay, but for now, let's go for 500 both. And hit OK. I showed you in the code. If you want to change these values, you can change it. It totally depends on where you're constructing it and how much amount of fire resistance you want to provide to it. Okay, and then hit OK. All right, that's how you define a beam. Now defining a column, again you need to do add new material. Add new property. In that, hit concrete. Now mention it as column. You can mention C1, C2 also, no issues. Let's take column something like let's take a square column. Let's take 400 plus 400 itself. 400 plus 400. Just type 400 here. Oh, we forgot to change the material property. See, one thumb rule or one thing which I have learned is that always, whenever a data book opens up in Etabs, go from top to bottom, see all the options one by one. Even if you know what you're doing, just it won't hurt to just see everything from top to bottom. See, now I just missed that. It was like 4000 psi, which was wrong. So M25 again. Now you check the values. Yeah, it is looking like a square. Modify by show rebar. Column is there. You have to change these values. HYSD 500, HYSD 500. Okay, that is done. We're defining column itself. Again, here see clear cover for reinforcement confinement bar is 440 mm. Well and fine. That's the minimum value. Okay, then hit OK. Now, for example, you have got multiple properties like this. Every time you cannot go and see if it is beam or if it is column, what is normal, normally cover provided everything. So we have one more option in this. For example, let me just delete this property. Okay, it is called as add copy of property. So now I want to add one more column, for example. So I do add copy of property. Okay, see by default it is M25. Okay, as we are doing columns, it is on column itself, and that's why the 500 is selected already for us. All I have to do is come here and change it. Right, see, let's just see, C is more than enough. C 500. star 500. Okay, now we'll just make it 500. I'll just make it 500. All I had to do was change the name and change the length and depth and width of the member, and then it okay. So when you have got multiple properties like this, you can do it. Just copy the property for column to column and beam to beam. Just change the name and change the width of it. Now it is very important to hit OK. Otherwise all the properties will go again. Okay. So that is done. What we have done so far, we have defined the metal property. M25 HYSD 415 HYSD 500 defined. We come for section properties, frame sections. We have defined the frames. Okay. And lastly, we have to define one more thing, that is slab sections. Go for slab sections. In slab sections, again, we have got one way and two way slabs. I'll hit one way and two way in the next model. Okay. In this, as we can see, it's all 8x8, so everything is two way. So delete the property. We just need one property. Modify our show property. Let's make it 150 mm. Again, from top to bottom. Let's go from top to bottom. Slab again 150 mm. It is very important to name it properly. Then we have to go for M25 shell thin, and slab is 150 mm. Hit OK. Now if you have a question how to define a uh, one way slab, I'll just show it to you once. Add new property, slab 150 mm, mention it as one way here. Alright, then do M25. Here you make it as membrane. When you make it as membrane, you get this option. Alright, you just change it, the option goes. Alright, so if you want to have one way slab, you have to make it as membrane and then use special one way load distribution, change it to 150 mm and hit OK. That's how you define a one way. If you're not mentioning it, by default it is take as two way slab. Okay, so for now we don't need one way slab. We'll discuss the one way slab in the next model. Let's delete this property for now. Let's hit OK. So now basically what we have done, we have completed step 1, step 2 and step 3 also. We have defined the frame sections, beam, column and slabs. Okay, next let's check snap options. How do we do that? Just right click it, snap options, and we have got all these options here. We need intersections. Basically what snap options is this, just show it to you. You've seen that red cross mark, that is basically the snap option. If you take it away, you'll not be able to see the intersection points and everything. Just do snap options and take whatever is required, like edges, we need intersections, we need fine grid and everything. Okay, this is what we require basically. Line ends and midpoints also we need. Intersection is not required, grid intersection is there. So this is what basically we're going to select and hit apply and then close. Right click, snap options, select these options, apply and hit close. So for the step also is done. Check snap options. Now model structure by using various draw tools. Alright, so we have got draw tools right here. Now the very first draw tool is a beam. So click on the beam part. You will get these options here. No matter what you're drawing, when you're drawing, this is a basic method to drawing things. That is, select whatever draw tool you want. Come here, see the option, see what is selected here, and then go here. This is basically 1, 2 and 3. This has to be the rhythm always, otherwise you'll end up assigning columns in places of beams and beams in places of columns. It happens to too many students. For example, instead of selecting beams, if I selected column, okay, and I have directly gone and started putting it here, but see, beam is here. Alright, so it's very important you go in a rhythm, 1, 2 and 3. Now in beam we have got two options. One is we have to draw a beam normally. We come here, we select the beam 200 cross 400 and you can see the plus mark, right? It will help you snap from one grid to next grid. Click it, drag and click it. As you can see in 3D diagram we have got a beam. Now I can keep doing this, go from here and drop it here, go from here and drop it, or I can do quick draw option. In quick draw option, basically what happens, 1, again 2, okay, 200 cross 400 is correct. I just come and just click it here, automatically it comes. All I have to do is just click. It will come. I don't have to go from one end to the next end. But the shortcoming of this tool is that it goes from grid to grid only. Okay. For example, if I want to draw by using this option, my beam is very big. Okay. My beam is coming from this end to this end. I can draw it. See, it is there. I select it up. It is one beam. It is not broken anywhere. But if I were to draw it from this option, what it will do is it will just take it like from this end to this end only. It will not go here because it's using grids as the endpoint. So that's the shortcoming of this, shortcut tool. Alright, so let me just delete all this. Okay, so now what you can do is select 1, 2, 3. You can keep drawing 1, 2, 3 like this for the entire structure, or what you can do is you can see one story and all stories here, right? One story basically in the sense you draw anything, it will just come on one story. All stories, it will come on all the stories. Let me just show it to you. I just select this entire frame. I have selected beams, so only beam part will get selected, not the column part. I have taken beam draw tool and I just let it go. It will come on all the floors because I have selected all stories. Okay, let me just quickly delete this. Now here comes a very important part. You have to understand the difference between one story, all story, and similar story. You understood the difference between one story and all stories, right? So what is the similar story is basically go to edit story and grid systems, modify bar show edit, this data thing. So basically this is your data, this is your entire building. Okay, each floor is 3 meters in height, elevation is 12. Let me add one more story. Keep extending story height 3 meters above fourth story. We'll add one more story which has a height of 3 meters. Hit OK and hit OK. Now basically what we have got 5 stories. Modify show options. I'll make this as foundation. I'll make this as plinth level. Okay, now my foundation is 2 meters beneath the ground. All right, okay, all right. So basically you look at the elevation part. My foundation is minus 2 meters beneath the ground floor level. I mean this one ground level. My plinth is at ground level 0 meters. Then my first story, the first floor slab level is at 3 meters from the ground. Second floor slab, third floor slab, and my roof slab. Alright, so my entire height of the building is 12 meters. Each floor is at 3 meters height. So at ground level I have got plinth, 3 meters up first floor, 6 meters up second floor, 9 meters up third floor, and 12 meters up I've got my roof slab. So this is basically, you have to come and change it if you want to understand what is going on in your building. Now we are going to discuss about the similar story, right? So for example, my roof slab and third floor slab are master stories. In the sense, these stories, for example, let me just make it no. Okay, and this also no. So basically what I have done, I'm saying each and every story is different. Now the stories are same to each other. Alright, but now if I make master story as yes, my third floor slab is master story. In the sense, I'm saying whatever happens in my master story will also happen similar to the third floor. Okay, so if I were to add any loads in third floor slab and I have a selecting similar stories here, automatically in second floor and first floor also those changes will happen. If I were to delete a beam, add a column, automatically it will happen in these also. Basically master story is something which is similar to other stories, and you consider that as a master story and you make all the changes in that story itself, so that the same changes will happen to the other similar floors beneath it or above it, doesn't matter. Okay, I have made roof story as none. No, because roof is, we apply roof load on it and we generally don't give that many walls and everything there. So load also generally will be less on roof slab. Okay, so let's hit OK and hit OK. So we have got one more extra, what do we call, floor now. So all story is there. Similar story. Now if you remember, my roof slab was not 1, 2 and 3. My roof slab was not a master story. So if I were to add anything, only in that case it will get added. I am in similar stories option right now. Let me come down third floor. Third floor is what I had given as master story, right? If I make any changes here, automatically come to the second floor slab also, first floor slab also. See, I am in what slab? Third floor slab. You can toggle up and down like this. I am in third floor slab, which is a master story. I'll hit this. See, third floor, second floor, first floor. All three of them which I had said, okay, this is master story and it is similar to second and third first. It will make the changes automatically. I hope you understood. In case if you have a doubt, you can rewind and watch it again. Alright. So now I just select all this. Let me just do all stories for once. Let me select all this. Let me just delete them here. In case you don't have delete option here, go to edit and you can delete from here also. No issues. I can hit it on your keyboard. Okay, so I'm going to draw beams 1, 2 and 3. Set everything. Automatically come everywhere. Next for columns, I'll select columns 1. This is a quick draw column option. 1, 2 and 3. See here, beam is there. I don't want beam, I want column. Let's take 400 cross 400, 500 cross 500, doesn't matter. I select that. You can come and drop it singly one after one for doing all stories. Or what you can do is delete this thing. Select 1, 2 and 3. Click and drag and leave it. Automatically all your columns are existing now. Okay. So that is also done now. Third option was slab option. Okay. This is all for a quick draw secondary beams and everything. We don't use this that much when braces also comes in the advanced level where I've got lateral loads coming in. And now we're going for slab option. Again, in this also we have got three options. I'll go with the easiest one first. It's again a quick draw option. Like how we have got quick draw beam, quick draw column, we have got quick draw slab also. Select it up. Again you see property 1, 2 and 3. Deck 1 is there, which is wrong. Which is slab 150 mm. We have got all stories option. We have selected this slab 150 and just drop it. When you drop it, automatically what happens, you get all the slabs and all the levels. So basically what we're doing is we took a quick draw option of a floor. We selected the 150 mm thing. We just got to the plan level and started dropping the slabs automatically. Now basically I don't want it, so I just select all these things. Just hit escape and I'll delete it up. Now if I want to draw, we have got three options as I said. First is the quick draw slab option. Just set the property and just drop it. It will come. It is coming because of the all story option. Then we have got second option. Select this and just zoom in, click, drag and drop. It's not working. Why? Okay. I don't know why the second option is not working. Okay, it's working. So basically what happens is you're drawing a rectangle basically. The second option is only for that. You select, drag and drop, it will come. The first option is the most used option in my experience because most of the times you don't have a clear cut slabs like this. There are openings in it. Sometimes you have got balcony in it. Sometimes balcony coming in attached to it, so and all. So you have to make some breaks here and there, and sometimes beams are running in between. So that point of time I just tend to use this option because I don't miss any node, which is very important, otherwise your results will not be proper. Just in case, for example, and this is also a bit tricky to use, if you just don't zoom in enough you can just end up dropping it anywhere like this. Again, then you have to go back and you have to change it. So don't be shy before just zoom in as much as you want, then select this option and just delete it for now. So zoom in as much as you need to, select the option properly, click, click, and this plus mark is very important because without it you'll not snap to the grid option. As you know, we have this snap option, we have done this grid intersection, so it is just snapping to that. So zoom in and do it. All right, let's go for quick draw option and just quickly draw all this. Now basically what is happening is, let me just take you down. Okay, so in foundation level we have got so many slabs. In foundation level we don't have slabs at all, we have got footings. So what we have done is wrong. It is the easiest method to draw, so we went ahead with it. Now we have to delete all this. Now it is very important to check, I mean all stories option. If I were to select everything, all the stories at all floors will get selected, which is wrong. So I have to do like one story, select it up and delete it up. So only in the foundation part it is gone. Next, coming up, plinth level. Generally at plinth level we don't provide any footings. If it is a ground level we don't provide anything. And right now our this building in particular is at ground level itself, it's a 0 meter elevation, so we don't have to provide slabs even here. Just make sure in one story select all these slabs and just delete them. Okay, all right, so our modeling part as much as like it is completed almost. Let's hit 3D, both are same. Anyway, so plan and just let's go to any floor. So basically what we're supposed to do after that point is, you have to go to plan, you have to go to foundation level, apply and OK. Make sure you're in one story, select the entirety of this thing, and you go to assign, joint, restraints, and give it fixity, apply and OK. Alright, so once you do that, your base is fixed, like how there is a footing and how it gets fixed like that. So basically what we have done right now is, we have completed model 5 or step 5 also, model the structure by using various draw tools. I have shown you almost all the draw tools except this shear wall draw tools and these bracings and these things which we use in advanced level. We don't use it at this level. So after this step, the next step is to go for loading. Now loads are very important. Which codes we are using in this, I have mentioned we are using IS 875 part 1, part 2, part 3 and 1893/16. That's basically earthquake load, wind load. All of these codes will be discussed in the next model. For now, as I said, the focus is to learn the software. So we just click this, we come to define load patterns. Okay, that's what we're doing. So basically what we have done so far, this is recall a bit. We have given the codes, we have selected IS system, then we have given concrete and rebar as material, we have defined frame sections, we have seen the snap options, then we have modeled them all, various draw tools, we have modeled them, we have modeled structure. Now we are going for define the dead and live loads. So basically what I'm doing is, I'm going for define, I'm going for load patterns. We have got dead and live load already. Now if we have used StatPro, in StatPro we have to apply the dead load onto the structure. In the sense, if you have a beam, you have to give the dead load of the beam also, but in this case it is not necessary. Basically what this self-weight multiplier is doing is, it is taking the structure. Let me just show it to you once. Go for define section property, frame section, we modify the section property. So basically what I have done, I have given the concrete, okay, in material it has taken density from there. All right, and I have got the, I have given the width and depth also to it, and density also is there from this metal property M25 modifier show. It has taken the density as to kilonewton per meter cube, has taken the density. So basically it is taking the density, multiplying the dimensions, and it is calculating the dead load on its own. How is it doing it? If you go for load patterns, you can see self weight multiplier is 1, for live load it is 0, for dead load is 1. Okay, so live load in the sense, whatever extra load comes onto the building, human beings walking around, everything, it comes in the live load category. Everything that moves, the load which moves comes under live load category. Now if I want to apply extra load, like for example, if you're designing a school building and you have got benches there, all right, you have got walls also. Now this walls and everything doesn't come under dead load. In dead load only beam, column and slabs, only these three things are covered. The dead load of beam, column and slab is covered. Walls and everything is not covered, because you can see we have not given walls anywhere. All we have done is define and apply and model the beam, column and slab. So now how do I apply wall loads? How do I apply this extra load, like bench load is there, or if you have got your bed in your room, if you've got some bookshelves in it. So how do I apply all that load? For that you can define a new load called as super dead load type. We have got super dead. This multiplier is 0. Add new load. So you can do that. Super dead load you can apply. If you want to apply wall load specifically, you can apply wall load. It also comes in super dead category itself. Add new load. Okay, and for roof we apply roof life. So right type roof life and apply roof life load. Okay, in next model we'll be going into much more depth. How do you apply wall load? How do you calculate wall loads? How do you calculate super dead load? You know, the slab I have given thickness as 150 mm, right? Let's go for define section properties, slab sections, modifier show property. 150 mm is what I have given, but in this generally we just don't leave the slab like that. All right, we have got some plastering work on it, right? If you have got put, you have sometimes you put even granite on it. So how do you calculate all that load? I'll show you in the next model how to do all that. That load, finishing and plastering, floor finish and ceiling plaster we call it. That load comes under this super red. We apply ceiling, floor finish and ceiling plaster we call it. That load will come under this. Loads will provide separately. Roof life will come for the roof part. Okay, so IS 875 part 1, part 2 will be discussed and we'll be doing the loads there. So for now let's go ahead and apply the loads. Now how do we apply loads? For example, if I want to apply slab loads, okay, now just selecting like this is gonna take too much time, right? We have got a shortcut for it. You go to select object type. Slabs are called as floors. Select them. Okay, so instead of me going and selecting each and everything one by one like this, shortcut is select object type and floors. Okay, now if you have got separate thickness of floors, separate thickness of beams and columns you want to select, there is option for that also. Okay, go properties, frame sections. See, from frame sections also you can select how much is beams. Just select beams, all the beams selected. Understood? So I want to apply now, slab loads first. So I'll go for the slabs. I'll select the slab load. I'll say the slab, sorry. I'll go for assign, shell loads, uniform. Okay, super dead, that is basically floor finish and ceiling plaster. Okay, I'll just apply as 2, apply. Okay, I'll go for select, get previous selection, assign, you go for shell loads, you go for uniform. Okay, I want to apply live load now. Live load apply as 2, generally that's what we apply. Okay, apply. Okay, don't get confused please. The multiplier is only for dead load, that is the dead load of beam, column and slab. For live load we have to apply the loads. For everything else we have to apply, except the dead load we have to apply loads for everything else. On slabs we apply that much and we hit OK. Just right click on it, right click on any slab and go for loads. You can see it, we have applied live as 2 kilonewtons, super as 2 kilonewtons. It's very important you verify this. Sometimes what happens, generally speaking, select object type, we select all the floors. Okay, we have done this. We come to assign, we come to shell loads, uniform, and we change the value directly here and we apply it. We don't see what we have, what option we have. We'll have dead load also. So we have applied as 2, and for example, okay, dead load 2, apply. Okay, I have done. So now what happened? Okay, dead load has come. Now how do I remove this load? The principle is same again. Select object type, floors, select. Let's keep this aside. Go back to assign, shell loads, uniform. Dead option is there, right? We applied dead load by mistake. So dead and delete existing loads. This is what it's supposed to do. Delete existing load, apply. Okay, right click on this, see, it is gone. It is that simple. Alright, so now slab loads are done. So what, let's do this thing. Select object type. We don't need we just need beams, right? Beams, select, close. Right click on this and say show select objects only. You do that, everything is gone, and it only works on the window which is active. For now this window is active. Now I have to apply wall loads. Alright, I'm gonna select all this. Generally what happens, and one more thing, it's very important to see in which story you are. That's why generally I prefer having both the stories, because when I select something, automatically I see if all the floors are selected. It is not selected there, which means only one thing, that I'm in one story option. So I go for all stories option, select this thing, see all of them are selected or not. Always have, until you go for the load application part, always have both the windows active. After that, for analysis part and all, you can have one window active, that is more than enough. But until you have applied all the loads and you have checked that you have applied all the loads, please keep both the windows open. Select all this again, all these beams you have to select. Okay, I have selected them. I go for assign, I go for frame loads, distributed. Again, see, there is that. It is very important. Whenever Alibaba opens up, go top to bottom. I'm gonna change this to wall load. Okay, I'm applying 10 kilonewton per meter wall load. I'll teach you how this load is applied, how you calculate this load and everything in the next step. Don't worry about it. I mean, in the next model, don't worry about it. For now, just understand how it is being done. Apply. Okay. All right, just hit the beam, right click it, loads, you can see 10 km per meter. Now in case if you have applied some load which is wrong, in case of applying 10 you have applied 100 kilonewton by mistake, how do you delete it? The same thing, select all the beams in which you have applied the load by mistake, go to assign, go to frame loads, distributed, wall load. Now here see, replace existing load is there, delete existing load is there. So you can either replace it or delete it, it's your choice. Okay, so we have applied wall loads and we have applied slab loads. All right, now there is one quick option which I think you have left out. So define the dead load and live load, assign the loads we have done, define the load combinations. Okay, so go for define. Last time we went for load patterns, this time we'll go for load combinations. Now you can manually add load combinations. Load combinations, I just do this dead load plus live load. Live is 1.5, super dead is 1. Sorry, everything is 1 because this is dead load plus live load case. Roof life, I'll come to the roof life part in just a minute. Okay, add new combination, 1.5 times of dead load plus live load condition. Add all of them, 1.5 live load, super dead, all right. So you make these two cases. Now let me just show you the code for once. I think in let's open the code book for once. Page number okay, page 68. In IS 456 page 68 you have got combinations here. Now dead load plus live load, 1.5 times of that dead load plus live load, and dead load plus wind load is there. Dead load plus live load plus wind load, earthquake load also is there. So we have got two conditions. One is serviceability and collapse. So deadload plus live load comes under serviceability. 1.5 times of deadload plus live load comes under collapse. Now we have not defined any wind load, so generally we're not touching wind load here. We have just applied dead load plus live load 1.5 times. That's what we have done in these two combinations. Now you can actually sit and you can actually define all these combinations, or what you can do is go for add default design combinations. What are we designing? We're designing concrete frame design. Okay, not composite beam. We're using concrete frame design, and convert to use user combinations is very important, because let me just show you once. I do this, I get these two options, but I cannot change anything. Alright, decon 1 and decon 2, I cannot change anything. Now add default design combinations. I'll do concrete frame design, convert to user combinations, and hit OK. Now I can change it. See, options are available to me again. But the problem is, if you open up and see it says they can dead load, super and wall load. There are so many, like live load it has not considered and everything. So that's a bit issue here. So generally speaking, the good approach will be to have a base file in which you have already sat and you have already defined all the combinations in it, and use that base file always before you start a project. Okay, for now just delete it up and hit OK. So now what we have done, we have actually completed the first building almost. Okay, we have to do this check model first. Alright, so I'm going for an analysis and check model, set all the options, hit OK. So no warning message is generated. So basically what this thing is telling me is, I'll select this for now. Do you see all these X marks? Okay, these are all like joint points. Okay, this is joint over there. So for example, if I had something like this, basically what I'm telling my system is that it is not connecting properly. So if I had an option like this, I have just made a change. I'll go for analysis, check model. Let me just put some big value like this, hit OK. See, it will just show up now. It will show error. Basically what my system is trying to tell me is that at roof slab F1 and B1 are too close. There is some error at so and so points. You can use the coordinate system here. You can just manipulate and go there. Okay, all we can do is select get previous selection. It will highlight it for you. So basically what it is trying to say is there is this like orphan node here. It is not sitting with any other node. It's very important that node to node connection is there. So that's the issue. Okay, that's a problem. If you have something like this and you run with it, you run the analysis and you get the values, you won't get the proper values, because there is no proper load transfer from this slab to these beams. As you can see, this is a two-way slab, right? So proper load transfer is needed. For that, proper setting of the slab is also needed. If there is no connection, there will be errors. So that is one way to check your model, to see if you have properly placed all the columns and placed all the beams and placed all the slabs into the proper positions they're supposed to be placed in. If you have missed out somewhere, this is the error you get. So it's very important you zoom in properly when you're drawing slabs. Generally in slabs you get this issue, because for beam and column we import a plan, right? So we know the location. Okay, so we have done check model. So check model, run analysis, and design the structure values, so get steel values. Okay, so what I have done is I've applied the load, I've applied the load combination and everything. Now I'm going to go for analysis, run analysis, or I can just hit this button. We have to save this file someplace. Let's do one thing. Let's go for desktop. Let's create a new folder. Let's name it as 1. Let's just save it. Okay. It'll run the analysis here. Alright, so this window is active. Now as I said, till load part you need both the windows to see if you're applying proper loads or not. After that you can close the window, no issues. Okay, So now a result part and everything we'll discuss in the second model, but I'll just explain what happens here. See, these are the these are three options you actually use. You can use that and go for display and get the undeformed shape and everything, road assignment and deformed shape and everything. Okay, so or you can come and click this show deformed shape, click on this option, you get combinations, click on whichever combination you want, hit apply and hit OK, and you just hover over it and you get to know how much amount of deflection is taking. Now we know that z direction is the vertical direction in the Etabs, so we're getting something like minus 11 mm worth of deflection there. And if you want to check a beam and column, this one bending moment and shear force diagrams, apply, hit OK. What I did, I came here, I selected this one, display frame bar, pierce, panel bar, link forces. Click that, you get the option. Right click on any beam and you get this all options. In the next model, we'll completely discuss what is this, how do we check the behavior of the beam. We have got dead load plus live load. What if we do 1.5 times of it? Everything we get all these values and everything. Okay, for now let's not worry about it. And if you want to get the final values at the base, let's go for plan and let's go for foundation level, tabulated. So these are the levels, these are the values I'm getting. 1562.60 kilonewton of force is basically being coming on that column. It includes everything, all the dead loads, live loads and everything it includes, and it will give you this value. You can change the combination also, the values will increase. See, this is basically what it is. Now let me just go do 3D model first. Okay, this option M33. Alright, so if you want to check the moment values also, just hit this option and do show values, apply, okay, automatically start showing you all the values here itself, how much amount of moment is coming. Okay, so if you want get moment values, everything. But the thing is, we don't get paid unless and until we provide them drawings. Okay, and for drawings you need steel values. How do we get the steel values? We go for design, concrete frame design, view by revised preferences, check everything. IS456 is what we are using, right? Yeah, so check all this 1.15, 1.5, all these values you check, hit OK. Design concrete frame design, select design combinations, what the combinations you have defined, select them, click design concrete frame design, start design bar, check. In the second model, I'll explain how the beam behaves, how the column behaves, how to check the behavior of slabs and everything. Now as you can see, you have got values here. We have got 858 mm square of area of steel at the bottom. Now generally what we do, we take in percentages, right? So we go for design, concrete frame design, display design info. The very first thing you're supposed to check is identify all failures. Okay, everything is passed. Design concrete frame design, design info. We have other option for that. Verify all members passed. 76 concrete frames failed design check. Do you want to select them? Yes. See, basically what has happened right now is all of them have failed. 45, 45. Okay, 1.5 times of it. Let's take this option. So basically what has happened is all our beams have failed. Design. Verify all members passed. 76 of them have failed. Yes. Show select objects only. See, none of the columns have failed. Almost all the beams have failed. Now how do we rectify this? And before that, let me just show you, also show all the objects. Display identify all failures was wrong. Rebar percentages, apply, okay. Okay, what I'm doing basically is I'm selecting all the columns only. Okay, see, now if any column goes beyond 4%, even 3 is too much, anything goes beyond 4, that column is considered as a failure. Because if you want to put the rebars on the site for a column which has 4% of steel in it, concreting that column will become very difficult. So as much as possible, we try to keep the values well within 2.5%. Sometimes in very rare cases we go for 3 also, but anything beyond 3.54 is actually considered a failure. Okay, 3.9, we have got 3.93, 3.40 is almost touching. Here see we have got 4.39. This particular column cannot be, it can be, casted on the field, but it will be very difficult because concreting and vibrating that concrete becomes very difficult. So how to make this columns and beams safe, everything I'll teach you in the next part. For now, as all the beams have failed, let's make them safe. How do we make them safe is simple. Okay, see the red part is what happening is it's showing all the failure of the beams. I just open the model up, define section properties, frame sections, 200 plus 400 I had given, uh, modify by show property. Okay, I'll make this as 500. Alright, and our columns are 500 and cross 500, so there's a lot of thickness there, so I can increase the width of the beam as well. There's no issue with that. I'll come up top here, I'll change the dimension here so that there's no issue later on. Hit OK and run this again. See, this is basically a iteration process, right? You don't get the building design safe in one go. No matter how experienced you are, even if the building comes safe, it will not be economic. So you have to keep playing with the dimensions here and there and to see the best possible combination of safety as well as economy. Now I'm going to go for and design concrete from design. The design but check I'll do. Alright, even now some more beams are failing. Last time how many were failing? 76, right? Verify all members passed. Now only 28 members are failing. Okay, I'll do show select objects only. I'll go to define again. Define concrete section properties, frame sections, add copy of property. I'll put beam 300 600 let's do 400 cross 500. This is actually wrong. We don't get 400 cross 500 kind of beams and all. I'm just trying to keep it safe. We have got 8 meters span, right? So 24 feet, basically approximately 24 feet. So such big beams I've just shown you. So 400 plus 500 and hit OK. Now what I'm going to do is I'm going to show you a tool. Okay, I'll go to select, get previous selection. All these things are selected. Then even if you're not getting this option, just click and drag and drop, you'll get it. I'll go for assign frame section properties. Currently they are 300 cross 500. I'm going to make it 400 cross 500. Apply, hit OK. So dimension of only these beams have changed. I'll run the model again. If we keep doing this, as long as all the beams and all the columns are not safe, we keep doing this. At the end we get everything safe. After we have got everything safe, then we try to cut down and see how much we can save and get economic design. Hope they pass this time, without have to increase the beam size again. So I go for design, concrete frame design, verify all members passed. See, all concrete members have passed the design check. See, these dimensions that I'm showing you right now are way out. Okay, just to explain how the modeling is done, I have done it. Next time I'll just even give you a proper a thumb rule, not which is practiced on the site for providing beams and columns dimensions and where to provide what columns and where to provide what beams. So let's go for 3D. Right click, show all objects. Okay, if you want one more window, we can get the another window from here, no issues. Plan level, we hit this and we come down. So basically I go for design, concrete frame design, display design info, rebar percentages, apply, okay. Now what I'm going to do is I'm going to use this rebar percentage and calculate how much amount of steel is required. Detailing is a complete different thing. Okay, designing is different, detailing is different. Now what we have done so far is designing process. We have designed, all our beams are safe, all our columns are safe. They're not economic, but they are safe. Now what we do is we take these values and we give it to the draftsman, draftsperson, and he or she will take care of doing the detailing part. In the future, hopefully, I'll make a separate course for detailing. For now, the design is completed. Okay, you have got your steel values, but you still not get paid because you have to give them the design drawings. For design drawings, you have to learn drafts, learn AutoCAD properly, and learn how to do all the beam column detailing properly. For that, you need to refer ISP codebook. So for the model one, I think we have covered everything. Okay, let's do a quick run through. We open up the file and we have done codes and unit used. We have defined that, we have defined material properties, we have defined frame sections, we have seen the check snap options. Then we have modeled the entire building. Then dead life we have seen. We have assigned the loads, we have defined the combinations, we have done check model, we have run the analysis. I showed you how we get you know this displacement and on the base values and moments and shears. If you want to check shear values, apply shears, apply OK. You get shear in beam and shear in columns. And if you want to check the axial load on columns, you can do that also. Hit here, hit axial loads, apply OK. See, you'll get this axial loads also on the columns part. Okay, see, the reason why I'm not going in depth for this results is because these results are not correct, because we have defined just two combinations and we have applied abrupt loads and beam size, column size, and all are very huge. Okay, when we're doing a proper building, we'll apply proper loads, we'll refer proper code books. Like I have mentioned here, IS 875 part 1, part 2, part 3. We'll go through all these code books and everything. We'll apply all those proper loads. We'll calculate how to apply wall loads properly. After doing all the loads, we go for load combinations. I showed you on the side. We'll apply all these combinations one after one. After you have applied all the combinations, we will run, and that point I'll explain the behavior of beams and columns, and how to check if your slab is failing, how to check if your beam is not enough. Based on codal provisions, I'll explain. I'll even show you the codes. Okay, so if you decide to take up this course, these are the things you have to you will learn in the coming models. The first thing will be the AutoCAD part. Stay the AutoCAD part. Okay, how to export, how to create, how to do all the purging and everything. Then how to import, then how to model that. Right now, what we did was we went for edit and we went for grid system, right? Edit and we went for what? Edit historical grid system. Modify the system. See, this is the option which we had. We went for spacing. We took the grid system and we did it. Next time I'll show you how to do it based on the model which is given to us. Then we have not done about moment releases. See, what are moment releases are done in secondary beams, right? Basically what happens is, if you come to the plan view, all the beams are setting from column to column. Okay, if a beam is going from beam to beam, or column or a column, like this one, see, column to beam, we don't get beams like this generally speaking. Okay, if any beam is going like this from beam to beam, it is called a secondary beam. Or if it is going from a column, for example, let me just drop a column somewhere here, and let me draw a beam from here. Let me just delete this first. Okay, we take a beam and we draw something like this. Okay, so anything that looks like this or looks like this is going from one beam to another beam. These beams are called as secondary beams. So for them, we do something called as moment releases. They'll be behaving like simply supported beams, although we provide all the fixity and everything. They'll be behaving like simply supported beams also. So you learn how to do moment releases. It's very important. Without doing moment releases, you cannot go ahead. And there is not a single building which I have designed so far which didn't have secondary beams in it. Secondary beams are always there in one way or other. They'll come. Then analysis of results. We'll analyze all the results. All the bending moments and shear forces and axial forces, what they are and what they entail, what they're trying to explain, what they're showing about the structure. We'll go into depth at that point. And behavior check for beams, slabs and columns, slabs, beams and columns. Okay, how to make the structure safe. I just showed you that right now. We had like 78 beams which were failing the first attempt. Second attempt it came to 28. Third attempt it came to 0. Then how to make the structure safe. I mean economic. We have not made it economic. What we did was we changed the values, and I have changed it abruptly. Okay, we cannot do that generally speaking. I'll show you that the design of beam and column, the same thing which I just showed you right now. We get all the values, right? Steel values, design values they're called as, and few other things are there. We have got wind load, we have got earthquake load, we have got to define, we go for load patterns. Still in the lock zone, unlock the model and define load patterns. Okay, I have to still add earthquake load like this. EQ, I do EQ, I come here, take seismic. Okay, add new load. Wait, modify load you do is see, if you're having 2018 version, 17 version, I think you'll get 2018 to 2016 version will get code. Okay, but that's not to worry, because let me just show you once. If I just modify lateral load, if I do, see, all these options are same in both the code books. Okay, 16 version also, 2002 version also, these are same. Okay, a few calculations we have to do. Okay, I'll show you how to do those calculations. We can do it manually, and we have to input it here. Then response spectra, I have to show you what is this response reduction factor, from where part to where part we take. So there is entire thing for seismic we have to cover. If I take wind, I apply wind here. All right, and I select where is the code? Acid 75 2015, add new load, modify lateral load. See, I have to explain you how do we do all this, from where do we get all these values. We have to refer IS 75 part 3 for this and get all these values first, and then apply on it, hit OK. So all these things are still left out. In the next two models we'll do it. As you can see, there's too much. Okay, so the approach of first learning the software, learning all the basic prerequisites was very important. I hope you have understood. If you have not understood, please go back and rewatch the video. I might have, you know, gone a bit fast here and there. In case you understood it, that's well and good. We can go for the next model soon if you decide to take up the course. And that's much about it for the first part. Okay, thank you. See you in the next class.